Hi class, let me introduce you to my chemistry friends, other chemistry teachers here at LaGuardia High School to help you succeed in chemistry this year.
Hi, I'm Dr. Ching.
Hi, I'm Mr. M.
Hi, I'm Miss O'Keefe.
Hi, I'm Miss Shake.
Welcome to Lesson 6 of Unit 1. Today we're going to examine what matter is made of. As we do this, we will identify the building blocks of matter, build atomic models of elements, and describe the components of an atom. Hopefully you recall from the beginning that chemistry is a study of matter and its changes. Matter is anything that has mass or takes up space. Matter is anything that has density. All matter is made up of atoms. There are 118 different atoms. Different atoms have different amounts of protons. They are called elements. They're all listed here on the periodic table of elements. Hopefully you recall that atoms have 3 subatomic particles. They are made up of protons and neutrons found in their nucleus and electrons that are found in an electron cloud that surrounds the nucleus. Take a minute to pause the video so you can complete this chart about the 3 major subatomic particles. It is important that you take note of the charge, mass, and location of each of these particles. So the charge is pretty easy to see here on the subatomic particles. Please make sure that you remember that a neutron is neutral and not negative. When we say relative mass, that's because the mass of a proton, neutron, and electron are infinitely small. So instead of measuring their mass in grams, we measure their mass relative to one another. So a proton and a neutron have a mass of 1 AMU, or atomic mass unit, and an electron has a fraction of that mass. We often see that the mass of an electron is negligible, or you can just discount it and consider it to be 0. Here you'll see the symbols that we use to describe the various subatomic particles. You can also find these symbols on reference table O. Finally, you can see in this column there are various ways to calculate the number of protons, neutrons, and electrons in an atom. Here's reference table O with the various symbols used to describe protons, neutrons, and electrons. There are a couple other symbols that we'll get to later on in the year. It can be noted that the top number of the symbol represents its mass, and the bottom number represents its charge. Here is an example of all the information you can find about atoms and their structures on your reference table. Take a minute to pause the video and copy this information into your notes. The first most important number is here in bold. It is called the atomic number. The atomic number always equals the number of protons found in an atom's nucleus. Notice how the element symbol and the atomic number are bold because they are always correlated. Often we do not write the atomic number because it is so well understood. Carbon has an atomic number of 6. Oxygen has an atomic number of 8. And potassium has an atomic number of 19. We do not have to write its atomic number because we know that the symbol always corresponds with the same atomic number. The number of protons in an element is always constant. This is not true for the number of neutrons or electrons. The number of neutrons can be indicated by the atomic mass. The atomic mass would appear in the upper left-hand corner of the symbol, and it will always be a whole number, as you can only have one neutron and one proton each. There's no such thing as a fraction of a proton or a fraction of a neutron. On our reference table, this number, however, is a decimal. This is called the average atomic mass. It is the weighed average of all the naturally occurring versions or isotopes of an element. Notice that our atomic number, which corresponds with our symbol, tells us the number of protons. If the atomic mass is the sum of protons and neutrons, all you need to do is subtract the atomic number from the atomic mass to find the number of neutrons. The next important subatomic particle to talk about is the electron. The arrangement of electrons in an atom is displayed here in the electron configuration. The electrons are understood to be closer to the nucleus on the left and further from the nucleus on the right. The electrons that are closer to the nucleus have the least energy, and the further they are from the nucleus, the more energy they'll have. The place in which they are found, the electron cloud, is actually termed an orbital, the likely location of finding an electron. Different orbitals have different amounts of energy, so these are called principal energy levels. Notice carbon has 2 principal energy levels. In the first principal energy level, with the lowest energy, carbon has 2 electrons. And in the second principal energy level, with more energy, carbon has 4 electrons. Carbon has a total of 6 electrons. In all atoms, there is a neutral charge because the positive protons will equal the total negative electrons. Now, many a times, atoms try to obtain more stable electron configurations by becoming ions. Ions result when atoms gain or lose electrons. Here are listed the possible charges of various ions. The charge of an ion is also called its oxidation state. When an ion has a negative charge, it gains negative electrons. When an ion has a positive charge, it loses negative electrons. The protons and neutrons in the nucleus do not change when atoms form ions. Here is a picture of a carbon atom. Notice that carbon has 6 protons in its nucleus. It also has 6 neutrons. Those 6 neutrons help determine that it has a mass of 12. Carbon has 6 electrons. The electrons in the lower principal energy level are 2, and in the further principal energy level are 4.
Because there are 4 protons, this is beryllium. The mass number is 9. The electron configuration is 2-2. This atom has no charge because the protons equal the electrons.
So I'm looking at this orbital diagram and I'm going to figure out what element it is. And since it has 12 protons, I know that the element is magnesium, since magnesium has an atomic number of 12. And I'm going to look at the protons and neutrons now, and those add up to 24. So I know that it's magnesium 24 with an atomic number of 12.
Hi, I'm Miss Shake. I'm going to do this problem with you.
Okay.
So this is an atom which has 16 protons. So if you see 16 protons, which is sulfur, and so I write S down because it's 16, and its atomic number is 16, which goes on the bottom. And then I figure out the atomic mass, which is 16 plus 16, 32, which goes on the top. And it's sulfur, and if you ever smelled sulfur, it's stinky. If you ever smelled your fart, it's stinky because of the sulfur that's in it.
All right. Hi, I'm Mr. M. We're going to do this problem. We're trying to figure out the isotope symbol of this atom. First thing you need to look at is the fact that there's 18 protons. Something with 18 protons has an atomic number of 18, so it must be argon. So start with argon. Atomic number of 18. Next, we could find the mass, which goes in the upper corner here. It's the sum of the protons and the neutrons. 18 and 22 is a total of 40, so it has a mass of 40. Next and last, I want to check the charge. I want to see how many electrons there are. There's 2 in the first ring, 8 in the second ring, 8 in the third ring. So 2, 8, and 8 is 18 electrons. 18 protons, 18 electrons means no charge.
Can you write the element symbol for this atom?
The term isotope is used to describe different versions of the same atom. Atoms can differ in neutron number, but they can never differ in proton number. When atoms have different number of neutrons, they will have a different mass, because neutrons and protons both have mass. Isotopes exist because this is the way in which elements were born during the Big Bang. Notice here we have 3 isotopes of the same element. We know that these are all atoms of carbon because they all have 6 protons. But these are different isotopes of carbon because they have different masses. The most common isotope of carbon has a mass of 12, and these 2 less common and radioactive versions of carbon have masses of 13 and 14 respectively. In addition to having different proton numbers, atoms can also have different electron numbers. When atoms gain or lose electrons, they form ions. Atoms form ions to obtain more stable electron configurations. When atoms have no charge, we'll see that no charge will be indicated in the upper right-hand corner of our element symbol. When atoms undergo charges, their charge of their ions will be placed in the upper right-hand corner. Here we have an ion with a charge of +1 and -1. The number 1 is not always written. Sometimes it is just a plus or a minus. Lithium has a +1 ion. That means lithium has lost 1 electron. So instead of having 3 electrons, a lithium ion only has 2. Fluorine has a -1 charge because it has gained an electron. Instead of having 9 electrons, fluorine ions have 10. In general, metals tend to lose electrons and form positive ions called cation.
Cations, meow meow, have positive,
while anions, notice this break up a negative ion, are negative. This concludes this lesson. See you in class.
I, sincerely, Rachel's daughter.